So now you all see what your notes look like. This is half of Unit 1. There's 3 units total the whole year, okay? And it's roughly a unit per quarter. Unit 3 goes a little bit into quarter 4, right before we start reviewing for the AP exam. But you can think roughly Unit 1 is quarter 1 and Unit 2 and so on, okay? What you are looking at is your notes, and we'll write in this, you highlight, I encourage you guys to use colors and highlighters, but that's completely up to you. Your notes are your business. I'm not going to police how you do your notes, okay? That's your business. I'm a color kind of girl. I love all my markers and my colors and my highlighters, so I use a lot of that stuff. But that's just from the teacher. So you'll see, I think you have 2 pages front back of, or a couple pages front back of notes. And it says 1A. That's like A is day 1 of 1.1. And then you can see if you keep flipping, you have a 1B. That'll be not tomorrow because we'll be in the media center, but Wednesday. After that, if you keep flipping, you'll get to the homework pages. Homework is the practice sets, okay? So one of the things, huge benefit to this class is I give you your notes. You don't have to print them. You're not drawing graphs. You're not writing out word problems. Huge, huge benefit to us. The bad thing is all the flipping you have to do in your binder. So just trust me that you will get used to it, just having to find where stuff is in your binder. I'll later on encourage you guys to use like Post-it notes and stuff to kind of, if you want, and I'll give you Post-it notes. I don't need you to buy them. I have lots. But just so you know, you have notes for 2 days, homework for 2 days, most of the time. Sometimes a lesson might go 3 days. I might split it up weird, but roughly A is day 1, B is day 2. And there's usually 2 days for every section. And then the homework's practice set 1 for day 1, practice set 2 for day 2, okay? So everyone should have this out. Freddie, you should have this out, okay? So we're going to start here. Always clear your RAM. And we're in a minute going to be going through some calculator stuff. Some stuff that we did last week when we were kind of playing and learning how to use the calculators. I'm going to go through a lot of that again with today's notes. And I just want you to know that you are used to whoever you had last year for math, okay? So you had Ms. Shackner or Ms. Baldock or whatever, and you got used to their way of doing things. And you will get used to my way, I promise. I don't change things around a lot. I'm very predictable. You'll see your notes up here every day. You come in, you get set up ready for me, and then I teach, then I assign the homework, and you can use the rest of the class period to work on the homework. Because of all this talking I have to do in the beginning, and because I'm going to go pretty slow through the notes today, first day of the pre-calc stuff, you won't have very much time to work on homework in class today, but tomorrow there's nothing assigned. What we are doing in the media center might take 5 minutes, okay? Like literally we have to go for the whole period for whatever reason, and then we're just going to be sitting there. So I would encourage you to not do your homework tonight. I said that. Don't do your homework tonight. Do it in the library tomorrow when we're all together. I'll be there to help you. You can work together then. If you really want to do it as homework, of course you can, okay? Or bring something else to work on in the media center because it takes 2 seconds to scan your computer and then we're there for the rest of the period, okay? So again, meet here and we'll chat and then we'll go. So just relax. Let's make sure we're paying attention. Do what I do. Pay attention to what I'm saying. If I say this is important, it means it's important. Although I say that way too much. I say everything's important. All right, so let's talk about the name of this section, Changes in Tandem. Don't get too hung up on the titles here. Change in tandem means change in together. Tandem's like with each other. And so it's just like how X's change, how X's and Y's change at the same time, and how that affects our functions, our graphs, and that kind of thing. Okay? This very first thing is one of the most important things we're going to talk about. I'm going to say that too much, but it is an important concept, okay? This right here made your teacher cry this summer. It did. I cry when I get mad or frustrated, not just when I'm sad, like a Publix commercial makes me cry. But I think I shared with you guys that I was a grader for the AP test. So me and hundreds of other AP pre-calc math teachers from all across the country met in Missouri and in Kansas City and graded AP pre-calc FRQ tests for 8 hours a day for 8 days straight, okay? It was ridiculously stressful and tedious, but I got paid very well, so that was good. But the most important thing is I learned a lot about how to make you guys get 5s on this test. And I'm telling you the truth. I graded these tests. I know exactly what they will say. Yes, they will accept that as an answer, and what they won't. I'm going to teach you how to answer the questions. It's not illegal. It's what I'm supposed to do. The proper way to answer a lot of these questions. So you'll hear me say, this is important. This wording is important, okay? So a function is a mathematical relation. What's a relation? A relation is just a set of ordered pairs. That's a relation. A table of values is a relation. That's a relation. That's a relation. That's a relation. Just it's lots of different representations of ordered pairs, okay? So a function is a mathematical relation that maps a set of input values to a set of output values. This is it right here. Such that each input value is mapped to exactly one output value. That is what a function is. Those words right there are the bane of my existence this summer, because in FRQ1, the questions are identical next year, okay? I already know what they're going to ask you, okay? You're going to have to answer if something is a function, yes or no. And on my test, too, this is going to come up, you're going to say yes it is or no it isn't. Just by saying yes or no, you can get a point. The second part of that question is why? And you have to state the definition exactly like that. So we'll keep talking about it. We're going to do it all year, because every one of my students is getting that point. I'm telling you right now, you're all going to get that point, because nobody got it this summer. Everybody was getting it wrong, and it made me cry. I was very upset about it. I was like, wait, but I know what they mean. They're like, nope, they don't get the point. So anyway, let's go on. I'll come back to that. The set of input values is called the domain of the function, is represented by the independent variable. So x values, guys, there's a lot of different words we use for x values. We can call it the domain. We can call them the independent variables. And y values have a lot of different names. Range, dependent, there's even more. Oh, output, underline input. So input, domain, independent variable, x values, all mean the same thing, okay? And then we can see functions in lots and lots of different ways. The rule of 4 is basically these 4 types of describing the same function. So for some reason, they wrote the function here, over in this box. We're going to be talking about this function 4 different ways. Graphically, numerically, which is like a table of values. Algebraically, if I plug in x, what do I get for y? Like working with the equation. And then, of course, a word problem, verbally, right? So all 4 of these have to do with this. Let's start with graphically. Now it's graph for us, but we're going to put it in our graphing calculator to help us answer the other questions, okay? So you should have cleared your RAM by now, second plus 712. You want to do that all the time. When you get to the homework, you're going to want to clear your RAM again, so you could type in the next type, and go up to y equals. Now listen, last period, this took a really, really, really long time, because some people weren't paying attention and they started late, so we all had to wait for them to catch up. So everyone do me a favor and try to stay with me, okay? If you get really, really lost or something, raise your hand, ask me. I'll stop and help you. But I just want you guys to start to learn how to work with these calculators and feel comfortable. Trust me, it will become easy for you. Nobody ever complains about the calculators as we go into the school year. Right now it feels scary. They're not. I promise, I promise, I promise. I'll tell you when to be afraid of something. This is not when to be afraid. All right, so we're going to type this in. Negative. Remember, this is your negative button down here. Negative 0.38. Now, instead of t squared, I'm going to put in x squared. What? Y equals. Yep. Nope, that's why we're going to use x. So x is right here. See the button that has an x on it? Hit that. And we want to say squared. So pay attention here, guys. This is your exponent key right here. So squared. Oh, sorry, let me make it so you can see. So notice how my cursor is up there, because it put the 2 up high like it's supposed to. We need the cursor to come back down. The way you do that is your right arrow. So your cursor should move right back down to the ground. Okay, that's the right arrow. And then continue typing. hit graph. Now, why does my picture look different than this picture? The window, proper word you used, very good. Window. So the word that says that, so this square is your window, so we're going to click on window, and default, your calculator defaults to 10 in every direction. So on your x-axis to the left, which is min, it goes to -10, to the right, which is x max, is +10. I'll come back to scale. Y min is going down 10, Y max is going up 10. That's always, it just goes out 10. That's your window every time you clear your RAM. We're going to change it to match this one. What scale means, X scale, Y scale, is it's counting by 1 right now. 1, 2, 3. You could count by tens. You could count by hundreds. Because, you know, in some of the word problems, we could have, like, big numbers here or something. We don't, so we won't play with that. So, like, X min, maybe I'll go out to -2. That's what that is, -2. What do you think I should go up to on X max? At least 24. I'm going to go up to 30 just to see what's happening over there. Then Y min. How far down should I go on the Y-axis? -20, right? And there's nothing even happening down there, really. And then up to, let's say, like 100. It's showing up to 80, but this is higher. Maybe just go up to 100. If you put in 90, are you wrong? Nope. You put in 80, are you wrong? Nope. You're fine. There's a lot of variation on what you can type in here. Now when you hit graph, it should look closer to what this is. Okay, so that's what window does. It moves that window to the part of the graph you're interested in. Okay, this first little task is to graph the point with an input value of 6. Input is your X value. So if I go to the right 6, I'm just going to go up and put a point. That's it. Just making sure you know what that wording is. Input of 6 would be that point right there. Okay? Now, we're going to complete the table of values. Look again, above graph is the word table. It's blue. So that means you have to hit your second button, and you should see a table of values. Now, again, it always defaults to 0, and then you can see your X values increase. You can arrow through this and see all the negatives. You can go to any number you want. So 0, our input at 0 is 0 is the input. Output would be 28. We need 6. And we want 12. Right? I mean, the harder way would be to take these and actually algebraically, like, plug them in. Like, put a 6 here and square it times that plus 9.4 times. I mean, a lot of work. We can use our table of values to help us with that. So you did all of that. You can hit graph if you want to. You don't have to go to the graph. I was just showing you. What we really want is the table, which is above graph. So second, and you can see your table of values there, yes? And so I just scroll through. So I'm just using my up and down arrow to scroll through. Don't worry about changing the window right now. So this is a good thing to say. If I were just needing to complete a table of values, it doesn't really matter what I see here. If I didn't change the window, let's pretend I just left it at how it was. It wouldn't have looked nice and pretty, but I still would have the same chart. So you don't have to change the window just to go to the table of values, okay? I was just kind of making a point, all right? So Olivia, I will help you. Okay, great. So are you doing okay, Evelyn? Can she kind of look on your calculator with you for this next part? Okay, so if the input value is 12.5, what is the output value? So if I go to my table, that's saying when x is 12.5, what is y? Well, guys, I could plug 12.5 in. Why would I do that when I have a table of values? But I have 12 and 13, but I don't have 12.5. Okay, so guys, listen. Where you're going to go is table set. Set the table. We want to change some settings in this table. Table set is blue, above window. Everyone stay with me. And we go to table set. And you can see it says on mine, if you look, if you can see, it says my table started at 7. Here's why. That's where the top number is right now. It's 7. Okay, so if I move that down, it's now going to say table start at 12. Watch, because that's the top one. Now look at the second thing. Change in table. That little triangle means change. Right now it's changing by 1. It's counting by 1. 1, 2, 3. You could change that to count by 50s, hundreds. What if this said, what if the input value is 2 million? Are you going to go through your table and scroll all the way to 2 million? It's there. It would take you an hour to get there. But that would be a way to change your table to count by millions or something, and it would just go like that. Or a best way to do, if you just want to find one number, is put that as your table start number. I want my table to start at 12.5. What that will do is put it as the first number in my table. So I'll go back to table. And guys, you can't mess it up. If you accidentally typed 120.5, go back and change it. It's not a big deal. 12.5 now is my top number. And now I know when the input value is 12.5, the output value is 86.125. Look at this notation. T of 12 point, oh, sorry. Can't see anything, can you? T of 12.5. So when my input is 12.5, my output is 86.125. Proper notation of an ordered pair. Okay? Yeah. Huh? If it's emergency, yeah, I'm just going to miss some stuff. So if you really have to go ahead and go. I'd rather you wait till the notes are done, but I know the notes are going to go long today. Okay, verbally, word problem. Go ahead and go. The temperature for a city in Colorado is modeled by the function T above, okay? Where T represents the hours of a day, so our input is time in hours, and T of T, the Y value, that one, the output, is the degrees in Fahrenheit at any time in a 24-hour period, from 0 hours to 24. I'll come back to that. Use the model. This is the model. Use the model to find the temperature at 6 o'clock p.m. So some of you might be familiar with military time, or if you've been to Europe or are from Europe, they use a different time way of telling time sometimes, and that is in a 24-hour period, 0 would be midnight. Okay, so like using these numbers, this is the temperature at midnight. At midnight, it's 28 degrees. At 6 a.m., it's already up to 70 degrees. At noon, we're at 86.08 degrees Fahrenheit. The question is, what's the temperature at 6 p.m.? That's not this, right? This is 6 a.m. How could we figure out what 6 p.m. is between 0 and 24? It's 18, because 12 is noon, and you just keep counting up, right? 13 would be 1 o'clock, 14 would be 2 o'clock. So 6 o'clock p.m. would equal 18 as my input, okay? You've heard 1800 hours, that's 6 p.m., right? So when we plug 18 in, what's the temperature? Let's use our chart again. I'm going to go back to table set. And instead of 12.5, I want to know 18. And it's just a nice, easy way to get that answer quickly. And you guys will learn these buttons. I promise you, okay? So table 18 will be right at the top, which is what I'm looking for. At 1800 hours, which is 6 o'clock p.m., it will be 74.08 degrees Fahrenheit. Okay? So we'll practice a lot using the calculators. All right? If you got stuck somewhere or you got lost, when I'm done with the notes, I'll come around. Let me know. I'll come help you one-on-one, okay? Or tomorrow in the Media Center is a great time to do it, too. You can work on that, too. All right, next page. Okay, we're going to talk about two separate characteristics of graph that are really, really important, really, really simple, though, okay? And so we're going to talk in this first area about how to tell, or naming parts of a graph that are positive versus negative. Let me tell you what positive means. It means positive, above the x-axis. All the parts of the graph that are above the x-axis are considered positive. Anything below the x-axis is negative, okay? Simple. How we name it is what can be confusing, okay? First thing is, it's asking for us to state the interval where g is positive. So let me just back up. This is the graph of g of x. G is his nickname. So it might say where g of x is positive or g is positive, but let's just talk about it. I think you guys would agree with me. I'm positive here. That's all positive, above the x-axis. This is above the x-axis, and this is above the x-axis. Those are the parts of this graph that are positive. How do we name it? Well, you guys have learned in your past, whether you remember or not, you have learned it at one time, about interval notation. Interval notation is something we use in this class a lot, and I will be reviewing it as we go through. Interval, this word, means x-axis. So what we're going to do is state what piece of the x-axis has graph that's above it, okay? For example, from -4 to 0 would be this first part. That's from -4 to 0. We're going to use parentheses to name that. Interval notation, you might remember, has parentheses and brackets going on in it. There's a huge fight amongst math people, truthfully, that some professors, books, teachers think that you should use parentheses for positive and negative intervals. Some say brackets, some say both. So what we have decided in AP Pre-Calc and AP Calculus next year will carry through, we just use either one. You can use brackets or parentheses. I like parentheses. I think it makes more sense. So I'm going to use parentheses, but just know on a test of mine or the AP test, you will not be tested on that part. If it was a multiple choice question, they'd give you only parentheses or only brackets, not a mix, okay? So it's really just knowing what part of the x-axis, okay? So you might see brackets in a key of mine because it doesn't matter, all right? Parentheses or brackets. So from -4 to 0, right? Then look, also from 5 to what? 5 to what? 6. Just that little piece right here, from here to here, that much of the x-axis. It's here to here. And then from 6 to 9. You could have also written this as 5 to 9 because the 6 overlaps, okay? So you could write it as, bless you, 2 separate or combine it, doesn't matter. Okay, let's look at the negatives. We're negative here, 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 below the x-axis. How do we name them? Careful, be careful. Remember, the x-axis is what we're looking at. So even though this is pointing down, that means it goes down forever, right? Where does it also go forever? Towards negative infinity, right? As this goes down forever, it's also going to the left, towards negative infinity. So that's actually negative infinity to -4. That's where it stops being negative, right? That's when it switches and goes to positive. Then, what are we going to put for the next one? What's the value I'm going to start with here? Careful. 0. How easy, probably -2 is what you guys meant, but how easy is it just to think -2? Because that's where the point is. It's confusing. But we want where it what part of the x-axis? So it's from 0 to what? Well, we can go, this is all of that is below, right? You could have broken it up. I guess if you want to do 0 to 2 and then 2 to 5, that would have been okay. But all of that is together, so I just kind of put it together. And then there's one more. This one's tricky. It starts at what? 9.
Negative infinity?
Oh, I know, positive.
Yeah, positive. Nevaeh, I feel like you're really getting this. But it's confusing because it's pointing down. It makes you think negative infinity. But remember, that arrow is pointing down, but it's also pointing that way. It's that way. So it's infinity. Okay? So you can see where people can mess up on that easily. So be careful. We'll practice it. Don't worry. Last thing I would talk about is the zeros of a function. I kind of skipped over reading this. Where we intersect the x-axis, those are called the zeros. There's 4 of them. 1, 2, 3, 4. Those are ordered pairs. You literally are naming points. Guess what else is confusing? These 2 are interval notation. These 2 are interval notation. And they look like ordered pairs. Those aren't ordered pairs. Those are chunks of the x-axis, okay? Here, these are points, right? Ordered pairs. Ordered pairs. So we have -4, 0. We have 0, 0. We have 5, 0. We have, is that 9, 0? My eyes are bad, guys. What do they all have in common? A y value of 0. If you're on the x-axis, your y value is 0. Okay? So those are just points. The zeros of a function are the x-intercepts. Zeros mean x-intercepts. Same thing. Interchangeable terms. Okay? So positive, negative. Now, same concept, same argument amongst math people is increase and decrease. Sometimes I skip over all the words. There's too many words sometimes. I can put it in my own words a lot easier, especially something this simple. Here we're going to be talking about increasing and decreasing. Different concept. Positive and negative above or below the x-axis. Increasing and decreasing simply means going up or going down. Now, this is important. You read a graph the same way you read a sentence. When you open a book, like when you looked at this, and if I told you to read the page, if I said, everyone take a minute, read the page, all of your eyes would start over here. We read left to right. Right? You don't start here and go backwards. That doesn't make sense. Same with a graph. We go left to right. So the reason I'm pointing that out is, like, for example, right here, I'm decreasing, right? The graph is going down. As long as I read it from left to right, if you were reading it from right to left, that would be increasing. That's why we have to all agree that we read left to right, okay? So let me just go ahead and finish with decreasing. You can be above or below the x-axis. It's literally where you have a negative slope is kind of what you're thinking. Left to right, going down is decreasing. And we're going to name our interval. The word interval always means x-axis. Same exact way as we did up here. Okay? So x-axis, what are we going towards to the left? Careful. What is this arrow telling me? From negative infinity. How confusing is that? I agree with you if you're thinking that. Because it's pointing up. It makes you think, oh, I'm going from infinity. We don't care what it's doing up and down. We care about left and right. As it's going up, it's going to the left forever. So from negative infinity all the way up to what x value are we going down? 0. We want to say -2, but remember, it's the x-axis. That's what we have to get comfortable with, okay? And you will. And then we start again at 5, right? And go to the right. Yeah. Remember, interval means x-axis. This is the same rule, again, whether you use parentheses or brackets or a mixture. We are not going to take points off for that. You can do either one. Okay, increasing, let's get this done. Increasing is from here to here. That would be from what to what? 0 to 2. From here to here. It feels weird, but we're saying what chunk of the x-axis are we going up? From 0 to 2. And then lastly, I didn't talk about it, but constant, you might have figured it out, is just going straight across horizontally. It's like get a little break from going up the mountain. It's constant. All right? Same thing. We'll go ahead and call that from 2 to 5. Okay? All of this is interval notation. All of that. Okay? Last page, last little bit. more about my tiers. To be able to name if a function is if something is a function or not is all about these words that we're going to practice. I didn't say it earlier, I don't think. This is part of the day I start forgetting what I've said to each class. But like there will come times in the year I'm going to pass out note cards and say write the definition of a function. And you can get an extra credit point for getting it right. Because I'm just going to make sure all my students get that point. No cheers for me next summer. I'm going to make sure of it. Okay, so here's the thing. In algebra, you could call, like we talked about the vertical line test. And I taught it like no repeat x values. You might remember some words like that from other teachers. It's okay if you don't. I'm reteaching it anyway. But at this level, we have to use this very, very specific language. And that is each input has one and only one output. That is the definition of a function. Okay, so we're going to decide if two relations are functions, yes or no, and we're going to have to state why or why not. So it is all right here for you. If it's a function, you have to say each input has one and only one output. Okay, now if a relation is not a function, you say it doesn't have that. Okay, so not every input has one and only one output. And you're going to give an example. Okay, and I'm going to show you exactly what I'm talking about right here. This is one of those things, day one of our notes, where I'm already talking about something that's such a huge concept in this class. It comes up throughout the whole year, too, this conversation. Here's a relation, a whole bunch of ordered pairs. We're going to state the domain and the range. You might have had teachers in the past that made you put it in order from least to greatest and stuff. It doesn't matter. At this level, you can put these x values in any order you want, but if there's any doubles or triples, any multiples of any of them, you would leave it out. You only write every number once. You should have no duplicates written in there. Same with the range, okay? Range is your y values. If you have any repeats in there, you don't write them. -2, 5, 6, -4, 5 happens again, so I'm not going to write it again, okay? But when we go to decide if this is a function or not, all of our x's only have one y. There's no repeat x values. That's how I understand it the best, those words. But since none of the x values repeat, this is a function. Notice I didn't say anything about the range. We don't care. These could be all the same number. It could still be a function. It's only the domain that dictates this. And you're going to write yes, because each input has one and only one output. That's it. Annoying. It's annoying, but we'll get over it. We'll deal with it. All right. This is a mapping diagram. Domain are your x's, range is your y's. The arrows mean they match up together. So like if I were going to write out these ordered pairs, I'm not. I would have an ordered pair of -6, -4, -3, 0. 2, 0, 2, -2, 3, -1. So let's start out by writing out our domain. Busy work, right? I mean, you're just listing the numbers. Any order, no repeats. Is this one a function? The answer is no. Because look, you have a repeat here. This x value has more than one y value. We have 2, 0, and we have 2, -2. So 2, the number 2, has two different y values. That's what makes it not a function. So no, not every input has one and only one output. And when it's a no, we have to give an example. Just doing this is good enough for me and for the graders. Just showing what are the two ordered pairs that prevented this from happening. 2, 0, 2, -2. Okay, this is why it's a no, because we have two x values that have the same x value has two different y values. Okay, that wording is confusing. It's very confusing to my brain. We're going to practice it all year. Don't stress. Last thing, takes a minute to do. We're almost done, I promise. I know today went long. We're just going to sketch a graph that meets this criteria. It's super important that you understand saying something is positive is different than saying it's increasing. Positive and increasing are different.
negative and decreasing are different. So if I had to sketch a graph that's negative and increasing, it would be below the x-axis, all my points below, and it would be going up. It would be going up. So for example, here's one. We don't have to worry about what type of graph this is, where it came from. Just know that it does not cross this axis because it's an asymptote, and it's increasing, right? It's negative below the x-axis and increasing. Positive, we need to be above and decreasing. How about this one? Same type of graph. This is an asymptote. It's not going to cross that, and it's going down left to right, going up left to right. So understand what the words mean. It's like learning a new language and understanding what those words mean in math land, okay? All right, I threw a lot at you. Remember, you have a few minutes to work on the homework. It's short, but you have all of tomorrow, really. So, like I said, it's up to you if you want to do it as homework, but you don't need to. I'm giving you class time tomorrow. I always put the key up here, and it's on Canvas. Label your homework. Label. Those are the only ones you have to do. I hardly ever assign all of them. I'm very intentional with what I choose for you guys to do. No busy work. Anyone have a syllabus thing? Yeah. No, I know. I printed those at the same time. Oh my gosh. Yeah. Well, I'm so sorry. Don't feel like you have to write it again. See at the top, this is your assignment. Problem 1, 2. The key to all the problems are always done. I just don't assign them. Okay. So, this is like the lady that makes this. This is for me. So, it's not that's my really handwriting. I go through every assignment and I pick what I write. And I get rid of what I don't. You have to, like, you never have to. But you could. Yeah, I did it one day and I got it. Bring your laptops tomorrow. Give your parents their homework. Goodbye, goodbye.